This is your video for week 5 for section 3.1. In this chapter, we're going to start talking about radian measure of angles. When we talk about radian measure of an angle, we're actually looking at the arc, which is part of the circumference of a circle, and the angle that intercepts that arc. In order to get an angle that measures 1 radian, what we have to do is look at the radius of the circle, and we have to look at the arc going along the circle that would have the same length as what this radius is. So if we took this distance right here and traveled that distance along the circle, that would put us somewhere around here. So that this distance along the circle from here to here would be the same as our radius. And now we're going to look at the angle that intercepts that arc. So the angle that intercepts this arc is this one right here. We're going to call that angle theta. If the radius of the circle is the same as the length of this arc, then the measure of this angle is actually 1 radian. Now, instead of measuring this angle in degrees, we're measuring it in a different unit, which is called radians. Let's look at some different angle measures and see what kind of radian measures that they would have. If we took an angle that was double the one that we had up here, so that the length of the arc along the circle was 2 times the radius, then this would give us an angle that would measure 2 radians. If the distance along our arc is half of the radius of the circle, then the measure of the angle in radians is 1/2 radian. And here's another one. If our angle is 360 degrees, so if it goes around the entire circle, that means that the distance of this arc along the circle, going all the way from here to here, is the same as the circumference of the circle, which is 2 pi r, and that would give us an angle measure of 2 pi radians. Now, an easier way to think about this is that where we have our angle theta and our arc length s, to find the radian measure of theta, we can just take that arc length and divide it by the radius of the circle. So in this one, our arc length was 2r, and our radius was r. If we just divide that and simplify it, we end up with 2, and that's a radian measure. We usually abbreviate radians as RAD. For this one, our arc length was 1/2 r. If we use this formula and divide that by r, then the r's cancel out and we just get 1/2 radian. And here our arc length was 2 pi r. We're dividing that by r and the r's cancel out, and that gives us 2 pi radians. When we use this formula, our two quantities here are both measured as lengths. So they're going to have the same units, and that means when we divide this, those units cancel out. So really, radians is not the same kind of unit of measure like feet or centimeters, because all the units cancel out. We do sometimes write RAD in there just to make sure we know it's radians, but a lot of times you'll see radian measures written without any units attached. In the last unit, we talked about all our angles in degree measure. Now we want to talk about them in radians, so we really need to figure out how to convert between degrees and radians. So let's take that same formula. If theta is s over r, then if we have an angle that's 360 degrees, the arc length, if we're going all the way around the circle, is the circumference of the circle. So the s would be 2 pi r, and then we're dividing that by r. The r's cancel out, so that gives us 2 pi radians. In other words, 360 degrees is equal to 2 pi radians. We can do the same thing for 180 degrees. 180 degrees is half of the circle, so the arc length would be half of this circumference. That means for the s on the top, we'd have 1/2 of 2 pi r, and we have our r on the bottom. If we simplify this, we can cancel out the r's, and we can also cancel out the 2's. Up here, all we have left is pi. So 180 degrees is equal to pi radians. We're going to use this to create unit fractions that we can use to convert from degrees to radians and vice versa. When we're using unit fractions to convert, what we're actually doing with something is we're multiplying it by 1. That means that we have something on the top and something on the bottom that are giving us the same measure, just in different units. So we're going to take this fact that 180 degrees is equal to pi radians. We're going to create 2 unit fractions out of that. For the first one, we can put 180 degrees on the top and pi radians on the bottom. Since these two are actually measuring the same angle, then this is actually equal to 1. Or we could do it the other way around, so we could put the radian measure on the top and the degree measure on the bottom. If we actually want to convert an angle from degree measure to radian measure, then we want to use one or the other of these 2 unit fractions. The way I like to think about this is that if we have an angle that's already measured in degrees, we want to get the degrees to cancel out. That means we want to use this fraction that has the degrees on the bottom so that the degrees will cancel with the degrees we have here. So to do this, we're going to multiply our degree measure by pi radians over 180 degrees. And then we can simplify that. And if we're writing something with an exact value, we'll leave the pi in there and we'll just write this as a rational multiple of pi. In other words, we might have a fraction times pi. If we're going the other direction from radians to degrees, then we're going to use the other unit fraction, because in this case we want the radians to cancel out and we want to end up with the degrees on the top so that that's our unit. Going this way, we would multiply by 180 degrees over pi radians and simplify. Let's do a few examples of this. First, we're going to convert from degree measure to radian measure. I don't really have to remember which one of these to use in which case. I just remember here, if I have degrees on the top, I want to use the fraction that has the degrees on the bottom. So I'm going to use pi radians over 180 degrees. That way when I multiply, I can cancel out my degrees, and the unit I end up with is radians. So this gives me 45 pi over 180 radians. And then normally I would simplify this. I want to cancel something out so that this number part of the fraction is as simple as possible. Now, if you don't like dealing with fractions, let your calculator do it for you. So for this part, I'm going to leave out the pi. If I just want to simplify this, I'm just going to put in 45 divided by 180. That's going to give me a decimal. If I want this as a fraction, I'm going to press my math button and use that first function, which is frac. That's going to turn that back to a fraction for me. That gives me 1/4. So that means that I could write this as 1 pi over 4, or simpler would just be pi over 4. 45 degrees is the same as pi over 4 radians. I'm going to do the same thing with this one. So I'm multiplying my negative 240 times pi over 180 degrees. My degrees cancel out, and that gives me negative 240 pi over 180. I want to reduce the number part of this fraction. That's going to give me negative 4/3, so I would write that as negative 4 pi over 3 radians. For this last one, since this is already written in decimal degrees, I'm going to write an approximation for the radians instead of using an exact value. I'm still using the same unit fraction, so I'm still using pi radians over 180 degrees. My degrees cancel out. That gives me 249.8 pi over 180. This time I'm just going to put this entire thing in my calculator to get an approximation. And notice on your calculator there is a key for pi, and that is right here above the caret. So if I do second and the caret, that will give me pi. Then I'm going to divide that by 180. For this one, I'm going to use significant digits. This degree measure had 4 significant digits, so I'm going to use 4 significant digits in my answer. And that would give me 4.360 radians. Now let's go the other way and convert from radians to degrees. This time there's no unit written here, which means it has to be in radian measure. To cancel out the radians, that means I want to put radians on the bottom of my fraction. The other way I can think about this is to get degree measure, I want to put the degrees on the top. I'm putting 180 degrees on the top and pi radians on the bottom. And so here the pi's are going to cancel out, and I just end up with 9 times 180 degrees over 4, and I can just do that on my calculator. That just turns out to be 405 degrees. Same thing with this one. I'm multiplying this by 180 degrees over pi radians. Technically this had radians up here, so the radians are canceling out. I'm going to multiply -5 times 180 and divide by 6 on my calculator. This was negative, so this is going to give me an angle measure of -150 degrees. Finally with this one, this notice is in radians, but it's not written with the pi. But since there's no degree symbol, that still means that it's in radians. I'm going to multiply this by 180 over pi, and I'm just going to put that whole thing in my calculator, and I'm going to use significant digits on this one. This had 3 significant digits, so I'm going to round my answer in degrees to 3 significant digits. That gives me 244 degrees. A couple of things that are really important to remember with this. First of all, if there's no degree symbol, so if there's no unit of angle measure that's specified, then it's understood that the angle is measured in radians. Make sure that you understand which unit of measure is being used and that your calculator is in the correct mode for that. It's really easy now that we're going to be dealing with both degrees and radians to get mixed up with your calculator, that it will give you completely wrong answers if you're using the wrong mode. Here's an example of that. The difference between 30 degrees and 30 radians is a very big difference. If we took 30 radians and converted that to degrees, this turns out to be approximately 1719 degrees. That's a whole lot different than 30 degrees. So just be very careful and pay attention to what mode your calculator is in.